This is a fraction test review for understanding fractions. This video is going to cover numbers 1, 16, 7, 11, and 13 in that order. We're going to start with numbers 1 and 16. I'm sorry if this is a little blurry to you, but you can also look at your test as you're doing this. Numbers 1 and 16 are pretty much the same type of question. It's just that the question is reversed. Where number 1, it gives you a fraction 5/6, and then you have to find the answer. Number 16 gives you the answer that would be in number 1, and you're looking for the fraction that number 1 has as an answer. So pretty much they're the same, just kind of turned around a little bit. Now, this is all about decomposing fractions, understanding what a fraction is and how you can break a fraction down into its basic parts. Now, you need to understand what a numerator and a denominator is. Now, right here, 6 is your denominator. You should understand that you have something broken into 6 equal pieces, and I've drawn, or try to draw 6 equal pieces of this rectangle down here. That is what that 6 tells you. It tells you you have something that is broken up into 6 equal pieces. Your numerator, the number at the top, tells you how many of those pieces you're talking about. So we're talking about 5 of those 6 equal pieces, which I'm going to mark out 5. Which means you have one piece that's not accounted for. So 5 out of 6 means you are looking at 5 out of the 6 equal pieces. Now, let's look and see what A says. A says 1 6 plus 1 6 plus 1 6 plus 1 6 plus 1 6. How many 6s are there? Let's count them. That's 1, 2, 3, 4, 5. That's exactly what we have right here. 1, 2, 3, 4, 5. The answer is A. There's another problem though. This problem actually has 2 answers. So we would have selected A or B as your right answer for this one, because 1 stands for your whole rectangle, which has 6 equal pieces, right? So 1 would be all 6 out of 6. Well, if you just take away 1 6 of those, what would you have left? You would have 5 6. Here's the 1 6 that we would take away. What's left? 5 6. So B is also the correct answer. Look at C. C says 3 6 minus 1 6 minus 2 6. Well, if you have 3 6s, let's say here's our 3 6s, and we take one of them away, you would have how many left? 2 6. Well, then you have to take 2 6 away. How many do you have left now? None. That would equal actually 0 6s. Then if you have 1 and you take away 5 6, well, that's opposite from B. Remember, we said in the beginning we had the 5 6 and we had 1 unaccounted for. Well, this one is saying that you're taking these away, which is going to leave you with the one that we have left, which equals 1 out of 6. So for this question, I would have accepted A or B as the right answer. That was a mess up on our part. Now, look at number 16. It says, choose the fraction that represents the equation below. Now, again, you have a numerator and a denominator. The denominator tells you how many equal pieces your rectangle, your pizza, whatever you want to think of, is broken into. So what I've done here is I have drawn 12 equal pieces on my rectangle. Now, you know these are not perfect, and it's hard to draw perfect equal pieces. So I've estimated those equal pieces. So how many of those equal pieces do we need? Well, let's count how many ones we have. We have this one, so let's mark it out here. We have the next one. We have another. Here's another. Changing ink colors, it takes me a second. And here's the last one. How many equal pieces is that? Well, let's count them. We have 1, 2, 3, 4, 5 equal pieces out of your total. What is your total? Your total is 12. So the answer is 5 out of 12. If it asked me how many pieces would be left, the answer would be 7, because there's 7 12s left. So that would be the answers for number 1 and 16, which were all about decomposing fractions. Moving on to number 7. Number 7 states, Ed has climbed 3 flights of stairs. He needs to climb a total of 8 flights of stairs. The shaded region of which figure models the number of flights of stairs Ed has climbed out of the total number he needs to climb. So we need to read with a pen here because there's very important information here. So we know that he has climbed 3 flights of stairs and he needs to climb a total of 8. Okay, again, think about your numerator and your denominator. Your denominator is your total number of pieces, which is 8, which means you have 8 in all. 3 tells you the number that we're thinking about or talking about right now. Well, if you look at this, this clearly has 3 equal pieces. So we definitely have the 3 right here. But do we have 8 as our total? Let's count. 1, 2, 3, 4, 5. 5. There's only 5. So this would represent 3 out of 5, not the 3 out of 8 we need. All right, look at C. C has 1 piece. It doesn't match our denominator. Out of how many total? 3. So that's 1 out of 3 equal pieces. Again, not the 3/8 that we're looking for. Hopefully you can look at D right away and notice there's a lot of pieces here. But how many pieces are highlighted? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 again. Out of how many is our total? I'm going to use my array. I know I have 4 going down. 1, 2, 3, 4, 5, 6 going across. That's 4 times 6. This is 6. This is 4. That's my area model, which would be 24 total pieces. Again, it's not really matching what that is telling me. Which of these would match it? Let's think about that. Well, here we go. 1, 2, 3. We have our 3. What we need for the bottom, our total. So 1, 2, 3, 4, 5, 6, 7, 8. And that is 3/8, which matches that perfectly. Now, there is an argument for D, but D is not the best answer. We're going to talk about a question like D in future lessons. So right now, you had to find the best model to show 3 out of 8, and B is the best answer for that one. Now we're going to look at number 11 and 13, and this got a lot of people confused. This is probably the most missed 2 questions that we had. I think a lot of it has to do with the wording, which is confusing, I agree. We got these questions straight off the LEAP website. So you do have to be able to understand what the questions are and what they're saying. So we're going to kind of work through this a little bit. The first one is number 11. It says use the models below to answer the question. Okay, so the first thing I'm going to do is I'm going to look at the model. I'm going to realize that this is 3 out of 1, 2, 3, 4, 5, 6, 7, 8. 3 out of 8 pieces. Again, this is 3. I can count that 3 in my right away. Out of 1, 2, 3, 4, 5, 6. So are these the same model? Is 3/6 the same as 3/8? If you have 2 different pizzas, think about it. You have 2 different pizzas. One pizza, you have 3 out of 6 pieces. They're the same size pizza. The other pizza, you have 3 out of 8 pieces. Same size. I mean, it's the same size pizza. This means there's more pieces, which means the pieces are smaller. Here, the pieces are cut in bigger sections, so the pieces are bigger. So, which statement about the models is true? Each shows the same fraction. No. We just said 3/6 is not the same as 3/8. These are not the same fractions. The sizes are different. Each shows the different fractions because they're different shapes. Well, they are different shapes, but is that really the best answer? Let's keep going. Each shows the same fraction because they have 3 different sections shaded. We've already said that it's not the same fraction. So this is not right because it's not the same. Now we have D. Each shows a different fractions because they both have 3 shaded sections but a different number of total sections. Okay, so here we're looking at different shapes and a different number of total sections. Which of one of these is the best answers? Okay, hopefully you picked D. And I kind of gave you that before we started. Remember, if you have a pizza and you're going to cut this pizza into 6 pieces and you have the same size pizza here and you're going to cut that into 8 pieces, these pieces are going to be a lot smaller. Well, not a lot smaller, but a little bit smaller because you're sharing with more people. So if you have different total sections, your sizes are going to be different. It's all about the size here. The 8 is going to have smaller size slices than the 6. So the shape really wasn't what was the issue here. It was the fact that the sizes weren't the same. So the answer was D for 11. Now, look at 13. 13 is a little different. I'm going to see if I can make that a little bit bigger for you. Well, it doesn't look like I'm going to be able to, so we'll keep going. All right. Use the fraction models below to answer the question. We have model A and model B. All right. Hopefully you notice, ooh, now it's letting me move things around. Let me just slide that off. Sorry about that, guys. There we go. That's what I want to do. All right. Now let's get back to business. Sorry about that. Use the fraction models below to answer the question. We have model A and model B. They're kind of fuzzy on my screen, so look at them on your test really closely. Now, what's the one thing we've been talking about with fractions? That the numerator is the number that we're thinking about, and the denominator is your total, and here's the key word, equal pieces. Hopefully right away you're looking at this and you're saying, wait a minute. These are not equal. This slice is clearly smaller than that slice. And this slice is not the same. So right now, they're not the same size at all. If you notice, the top section is going to be a lot smaller than the bottom section. So, are they the same? No. Can we even make a fraction out of this one? We can't. I mean, it doesn't have equal sizes. So you really can't make a fraction out of this one. This one we can because we do have equal sizes. So this one, our fraction would be 1, 2, 3, 4, 5, 6, 7, 8. This would be 2 eighths. This one I can't make a fraction out of all because the pieces are not equal, and that's what's key to fractions. So are they the same? No. So A says the models are not the same. This is true because model A is different shape than model B. This is a true statement, but is it the best answer? Let's keep going. B, the models are not the same. This is true because the sections of model A are not all the same size. Fractions are made of equal parts. Again, this is another true statement, so we're going to leave that one alone. The models are the same. We've already said they're not, so C cannot be the right answer. The models represent the same. This is true because models have the same total number of sections and the same number of shaded sections. Okay, so out of the three, A, B, and C was what we're going to look at. We've already discussed the shape is really what's not important here. What's important is that the sizes are the same size because fractions have to be equal parts. So this, A, is not the right answer. B talks exactly about that. Fractions are made of equal parts. They're not the same size, so therefore they can't be the same one. I'm thinking this is our best answer. Let's look at D one more time just to make sure. This is true because both models have the same total number of sections and the same number of shaded sections. Well, that may be true, but are they the same size? No. So the correct answer is B. Okay, hopefully you're going to be better at looking at these types of questions, reading with a pen, and being able to answer questions like this in the future.